Hello, we are Bioenrichment Engineering, and today we will be presenting our design project, which explores the enrichment and purification of natural colorant from sour cherry pomace. We are a team of 4 chemical engineers who all share a passion for the study of sustainable advancement in biochemical applications. Presenting today is Alex Bopp, myself, Emily Hilton, Larissa Markewic, and Skylar Stephenson. The design problem was presented to us by Keeley with the objective to design a new processing line for the extraction and purification of anthocyanin pigment from a sour cherry pomace. A local Saskatchewan cherry producer was interested in finding an alternative for the cherry skins, or the pomace, that are usually discarded after the juicing process.
Anthocyanins are polyphenolic compounds that give red, blue, and purple colors to various fruits, flowers, and roots of plants. They are commonly found in various fruit and cereal crops within Saskatchewan, including cherries, blueberries, Saskatoon berries, barley, and wheat. Their color varies based on their pH, and they are very heat sensitive. They are also known to have many health benefits, including that they are antioxidants, have anti-inflammatory properties, are antiviral, and can possibly prevent cancer and cardiovascular disease. The demand for natural food colorants is expected to continue growing as consumers become aware of health hazards associated with synthetic products. As there is concern over the possible carcinogenic agents in artificial dyes, the United States has banned all artificial dyes, and there are limited amounts used in Canada. Because of the health benefits, anthocyanin pigment could also be marketed as a natural health product in addition to a natural colorant. Also, the pomace is currently not being fully utilized in Saskatchewan, as it is spread back onto the land after juicing and jam or jelly processing. Thus, this process provides a direct link between innovative industrial production and sustainable agriculture practices in Canada. The process of producing natural colorants is also more environmentally friendly, and the products themselves are biodegradable.
So here is an outline of the conceptualized flow pattern for industry process design. The extraction step was accomplished by the addition of 70% concentrated ethanol in warm water, followed by solid liquid separation and evaporation. Next, purification of the anthocyanins was achieved by the use of membrane fractionation and radial flow chromatography. In the final stage of the process, the purified colorant was dried to a powder using a closed-loop spray dryer. We simulated 4 complete process designs, a combination of ethanol extraction with nanofiltration versus radial flow chromatography, as well as the use of water extraction in the place of ethanol. So we determined that the addition of water was the most feasible in this process to extract anthocyanins. Water at 60 degrees Celsius is optimal for extraction to prevent degradation, and to maintain the structure of the anthocyanin pigments, extraction was performed at a pH between 3 and 4, and we accomplished this with the addition of citric acid. So we determined that radial flow chromatography was the best alternative for purification, as there was more potential to increase the purity of the final product. Radial flow chromatography is a unique technology that offers greater flexibility, requires less solvent, and has a smaller footprint.
With the specified annual throughput and 6-month operating time, the radial flow chromatography process obtained a final product that was 21.6% anthocyanins. Our product selling price was based on the product purity and sale as an antioxidant supplement powder. From our economic analysis, we determined that with a capital expenditure of $4.3 million, the low starting anthocyanin content of sour cherry pomace resulted in an unprofitable product. However, the process design itself was feasible, and with further investigation, we were able to determine some recommendations to improve profitability. Our first recommendation was determined after varying the starting anthocyanin content in our process. We found that a feedstock containing a minimum of 25 milligrams per gram of anthocyanins with the same throughput of 100 metric tons per year would result in a profitable product. Wild blueberries and purple corn, both of which can be found in Saskatchewan, as well as dried bilberry, contain anthocyanin content within our determined range. Another option, which would encompass more local fruit varieties, would be to consider extracting total phenolic content of fruits. The sour cherry pomace we based our process design on has a total phenolic content above the determined 25 milligrams per gram minimum, as do lowbush blueberries and hascap berries, all of which are grown right here in Saskatchewan. Our process design has the potential to further expand Saskatchewan's agricultural practices, while improving the health of society through the consumption of antioxidants as either supplement powders or natural colorants. Thank you for listening to our presentation, and we will be available to answer any questions at the end of the design showcase.